Okay. So let us find VM. So VM shall
Yes,
be the
teacher.
square root of 306. Okay. And VM is equal to
17.4.
17.49 or 17.5. I say 17.5 centimeters. And whoever got that, I marked you correct with no fear and with no favor. So that's how we get VM. Those ones have just joined, are doing this question number 13. So let us look at the next part where we have to find VQ. VQ. So if you have understood how we found VM, I want you to tell me how we find VQ, the distance VQ. How do we find the distance VQ?
We'll use the triangle VMQ.
VMQ. We use the triangle VMQ. Okay, VMQ. All right. All right, we can use VMQ because now we have got the value of V what? Of VM. We have also obtained the value of VM. Okay, so now this one here is 90 degrees there. It is 90. That one is obvious. It is 90 degrees. Okay, so let us draw V. I'm drawing. Let me zoom out a bit so that you can see. I'm drawing VMQ like that. So where is 90 degrees? 90 degrees is at point what? Is at point M. 90 degrees is at point M, at point M. So even me, I'm going to put 90 degrees at point M. Okay, so here I'm putting M and I'm putting 90 degrees. Okay, so this is V and this one is Q, like that. So MQ is 6. So I'll write MQ is 6 centimeters. And then VM, this slanting edge, VM, which I've obtained as 17.5. I'll write it as here 17.5 centimeters. Then again, I'm going to use Pythagoras theorem. So this is your C, this is your A, and that is your B. Like that. So you say C squared equals to A squared plus B squared. So it is my VQ, which is squared, which is equal to 17.5 squared, then plus 6 squared. Okay, so VQ shall be equal 17.5 squared. I'll get 306. Without fear or favor, it is like this one here, 306. Because if this is the square root here, then if you square this, you come back to 306. Then plus 30 what? 36. So there, what I get VQ squared equals to 300 and what? 42. And then I find the square root. I find the square root of 342. It is equal to VQ. So VQ there shall be equal to, if I find the square root, I get 18 point what? 18.5 centimeters. So that will be our correct answer if we are to find the value of VQ. That will be the most correct answer of VQ. So you can see that VQ is here and you can get the value of VQ. There are things that you can do. You can also do it in another way. It is, what if VM was not known? What if the height was not known? You can get VQ, but that one requires you to first get the diagonal SQ. You see the diagonal SQ. If you want to use the height here, you can get the diagonal SQ. Let me show you this. because I'm not so much in a rush of you to do what, but I want you to understand. So let me give you another alternative if you want to create that, if you want to get the answer to that. So let me just redraw it here very fast and show you what I want. So we can first get the diagonal. So if this is S and this is Q, this is an alternative to VQ. You can first get the diagonal. So I'll first draw my diagonal there. There, that's the diagonal I want to get. Okay. And I know the center. So let's assume that the center was somewhere here. Okay. So I'm drawing these dotted lines, the ones which were there previously. So that's where the center. So the center is here. There like that. Okay. That is where we have O. So let me draw it straight because last time it was a bit confusing some of you, but let me see. Let's put some trick here. Make it maybe somewhere here. Somewhere there. Okay. So this time I'm going to make it short there. So this is V. That's V there. Then I want to find VQ. So I can join this to that. Okay, something like that. I think you can see that. So it means that this one here is also 90 what? It's also 90 degrees. That one is also 90 degrees there. Because this line touches the base. At every point around this base is just 90 degrees. Even if here. So it just touches the base at 90 degrees. At the same way you may have this pen here like this on this paper. So the angle between here and here is 90. Everywhere here is 90 what? Is 90 degrees because the pen is perpendicular to the paper. So even this line here, it is there. So the angle in between there is 90 degrees. Everywhere it is 90 degrees. So that's why I'm going to put here 90 degrees like that. Now, the alternative I'm telling you is that if you want to do this, then you have to first find the diagonal SQ. You can find the diagonal SQ, then half of that diagonal you get OQ, which will be here. Remember that our height is 15 centimeters. Then you can first find the diagonal SQ. How do you find the diagonal SQ? So it means that now you have to first consider this triangle which is here. That's the good thing with 3 dimension. You must be able to look at every point. And you know that all these are 90 degrees. So you can look at SP like that. Okay? So we can first find the diagonal SQ by drawing that. So we can draw this triangle here, this one here. You can draw this triangle here, and this is the triangle S. You see the slanting, the diagonal part is SQ. So I'm putting SQ here, and then I'm putting P here. Okay, like that. The P, that's where I have 90, and that's where I've put 90. So SP is 18 centimeters, and PQ is 12 centimeters. Then I can find SQ. If you say that this is your C, this is your A, and this is your B, so you say that C squared equals to A squared plus B squared. Then my C is SQ squared equals to A squared, which is 12 squared, then plus 18 squared. Okay, and I'll get, okay. Are you seeing those things on the screen?
Yes, teacher.
Okay. So plus 3, 2, 4. So if I add that, 144 plus 324, we get 468. This is SQ squared, SQ squared. Now we find the square root of 468 and it shall be SQ. So I get 21 point what? 0.6. Okay, 21.6. That is SQ. So from here up to here, 21.6. Now just know that point O is somewhere here. Is this point O which is here. Now I have to find OQ. What is OQ? So OQ from that point there, if I want to find OQ from there, I will say that my OQ is a half of what? Of S what? SQ. It's a half of SQ. So it means that it's going to be a half times 21 point what? 21.6. And I will get, so 21.6 divided by 2, I'll get 10 point what? 10.8 centimeters as my O what? My OQ. So it means that here I have 10 point what? 10.8 centimeters there. Okay. Now my screen this side, I think it's power problem. You are seeing those dancing things on the screen, eh?
No.
Okay, good.
No.
All right. So the next thing that I'm going to do is I'm going to use VOQ for me to find VQ. VOQ to find VQ. Because VOQ is a right-angled triangle. So I'll come and draw this triangle here. Sorry, you're not seeing, but I can show you. Okay, so you ask yourself, where is 90 degrees on VOQ? On VOQ, where is 90 degrees? 90 degrees is at point O. So even you at where there's 90 degrees, that's where you put point what? Point O. And then you come back and ask yourself, what is this other part that is at the tip? It is V. So even you here, you put V, and then this one is what? Is Q, like that. So OQ, we have said it is 10.8 centimeters. And my VO, it is 15 centimeters. So I want you members to try out and find for me VQ using this other method. So this is C, this is A, this is B. Using your Pythagoras theorem, what do you get? So try out, because we have just seconds left. Try out, but we can see it is C squared equals to A squared plus B squared. So it is VQ squared, which is equal to 15 squared, then plus 10.8 squared. So try out and compare your answer, whether it is the same like the last one that we found. So in case we don't finish this, you finish it on your own and then you resume back the lesson.